Divide by 0.25. Hey, can we divide by a decimal? No. So when we do go to divide that, let's slide it over so it's 4,500 divided by 25. And then reduce first and then do your long division. But that does come actually really nice out. It's just 180. Woohoo! Alright, now I know you also did sales prices and discounts and things like that. There's different ways to do this one. So the original price of find the original. So we're finding the original price. If the sale price is $78 after 25% discount. Discount, does that add or subtract the 25%? It subtracts. Okay, so there's many ways, whatever you're most comfortable with. I take the sales price and I subtract away the 25% of the price and set that equal to 78. And so really this is 0.75 of the price, because that's 1 take away 0.25 equals 78. Is that one of the ways that we learned last year? Okay. If you like that way, keep it. If you like your way from last year, that's fine. Different methods. All right, and then we divide by 0.75, and again, we can't divide by a decimal, so it becomes 7,800 over 75. Reduce it and do your long division, and it comes out really nicely to 104 actually. All right, now that's a price, so what do I need to do to my final answer? $sign, perfect. Mr. Sharma. All right, well let me know if you want to ask again. Okay, so same thing on number 5. It says last year's salary, but there was a raise. So instead of discounting taking away, we are going to add on the raise. And now the new salary is $44,200. So I'm going to use S for salary. So we take last year's salary and we added to it 0.04% raise. Well, it's not not 0.04%, it's just 0.04 is equal to the 44,200. So I'm really looking at 1.04s, because again, one salary plus 0.04, that salary is 1.04, is equal to 44,200. Divide by 1.04, and we get S, and I'm going to make 44,200 and add 2 more zeros because I'm sliding those over, 104. That's a big old number. 4 million! Okay, and that comes out to be the salary is 42,500. Now that's salary, so what do I need to do to it? $sign again. Very good. All right, so the next 2 problems are going to be mixture problems. That's mostly going to be tomorrow's topic, so I'm going to slide you into it today and then do a whole bunch tomorrow to get you ready. But when we're doing mixtures, we're just taking, maybe say 2 things, putting them together and making a new product. Yes? Okay, now mixtures, let's talk about them a little bit. A lot of times you'll see like it's full of 50% acid solution. If it's a pure whatever, it's going to be 100% acid or saline, just full of it. So put that on the side in case you see that in your homework somewhere. What if I say I'm mixing water there? How much acid is in water, hopefully? 0%. So we got to have that down just in case. Now, your let statements are going to be really crucial on here to make sure that we understand. All right, so basically the gist of this is that a chemist wants a total of 12 liters. And the stockroom only has this type, 40% and 70%. So I want to take these 2 things and put them together and make the total amount. Now let's talk about that. If I have between 40 and 70% and I start mixing them, I can make 50%, 60%, 65%, 69%. Give me an example of something that I cannot make. 80%? Or Lower than 40, 30%. I can't do that. So the 70% will give more to the 40%, and the 40% will water down the 70%. All right, so leave some room for your let statements, but then we're going to show over here that we're taking two items, adding them together, and we're going to make a total. So I'm going to say solution 1 plus solution 2 equals total solution. And that works for any two things that you're mixing together. So always set that up and be ready for that. All right, let's go back to our let statements. So what's interesting is I'm going to do 3 let statements as well. One for solution 1, 2, and a total solution. So I'm going to leave a space, and I'm going to say, I'm going to go into my last sentence that says how much. How much is an amount of each? So that's important to note as well. So I'm going to do amount of solution 1, amount of solution 2, and amount of total solution. And then the other thing I'm going to do is I'm going to make a line right here, because this one plus that one is going to equal the total amount. What do we think so far? Good so far? All right, now, doesn't really matter which one we say is solution 1. So how about we go in order? Let's write 40% under the solution 1 and 70% under the solution 2. And then what percent does he want for his total amount? 50. How much does he want of his total amount? He wants 12 liters. We know automatically that that's 12 liters. We want the total added to 12. But I don't think we have any more information, do we? So let me pretend this. What if I had 10 liters of the first? What would I need to go right there? 2. How did I get 2 from the 12 and the 10? I subtracted it from the 12, right? So say I said this was x. You said I subtracted that from the 12. 12 minus x goes right there. Do you see how if you add those together, the x's knock out and we get back to 12? Yes? Okay, so again, if that one's 10, 12 minus 10 is 2. All right, so here's what we're going to do now. Into each of these, we're going to do amount, percentage times amount, percentage times amount, and percentage times amount. And we have them all really laid out really nicely right here. So here's the percentage for solution 1, 40 times x. In solution 2, careful, it's a quantity, so it's 70 times all of 12 minus x. And the last one is going to be what times what? 12 times 50. Good. Does it matter what order I put those in? Like, could I do 12 times 50 or whatever? Not really. I always try to keep it consistent. So it's percentage amount, percentage amount, percentage amount. So I can check it all the way through. All right, so 40x plus 840 minus 70x is going to be equal to 6,600. So I have negative 30x plus 840 is equal to 600. Subtract over 840. Negative 30x is equal to negative 240. Ooh, what's that rule about having matching zeros at the end?
Cross out.
Cross them out. I'm really dividing by 10. So it's just negative 3x is equal to negative 24. So divide by negative 3. 8. Now here's important. X is an amount, so x has to be a positive. because you can't have negative 8 liters. Now, the question said how much of each. So we wanted 8 liters of the 40%, and 12 minus 8 is 4 liters of the 70%. Okay, so coffee company wants a new flavor of Cajun coffee. So this is the total. Can you write total above that? How many pounds? So see how I picked up that word? How many pounds, that's our variable, of coffee worth $7 a pound should be added to 14 pounds of coffee worth $4 a pound to get the mixture is the Cajun, worth $5 a pound. So again, I'm adding 2 different kinds to get my total. So underneath this though, instead of being percent times amount, I'm going to do what times amount? $sign times amount. We'll do number 1, $sign times amount of number 2, and $sign amount of the Cajun total. Alright, let's set up our let statements. Let, I'm going to set them up, be the amount of 1, the amount of 2, and I'm going to make a bar equal the amount, total amount. Amount total. All right. How many pounds of coffee worth $7 a pound? Let's make that first one the $7 a pound. And the second guy is worth how many dollars a pound? $4 a pound. And then how much is my mixture worth? $5 a pound. Now, how many pounds? That indicates the how many? There. How many? Variable. How many or how much always indicates the variable. So amount 1 is going to get the variable of x. 2. What? Oh, they already gave us the amount. What's the amount for number 2? 14. So what's the total amount that goes down here? X plus 14. Great job. Alright, so just like the last one, now we're going to go through. Go to the first guy. $7 times x, 7x. Second one, $4 times 14. And the last one, do not forget your parentheses. $5 times x plus 14. Now, before we go any farther, the total amount is $5. So which one will have more by the time we're done? Which one's closer, 7 or 4? 4. The 4. The second, we should have more of the second amount. Alright, so we got that idea before we start. That's good. Here we go. 7x plus 56 equals 5x plus 70. Subtract over 5x. Right. Subtract over 56. Right. 2x is equal to 14. Divide by 2. X is equal to 7. Now that's amount number 1. That's 7 pounds. So amount number 2 is 14 pounds. And the amount number 3 should be a total of now 21 pounds. Not that we need all of those, but take a look at it. Does the $4 one have more pounds?
Yes.
A lot more pounds, doesn't it? To answer your question, how many pounds of the coffee were $7 a pound? 7 pounds of coffee worth $7 per pound. So your let's say